Hello everyone, welcome to another episode of My Tech Dives. In today's episode, I want to talk about some deep technical concepts to uh, non-technology folks. Why I chose this topic is because in today's work environment, there are a lot of people uh, like business analysts and other generalists who love to talk with technical people in order to gather many inputs for the projects. Sometimes they love to even talk to technical clients, and a lot of jargons are being exchanged, which our folks find it very difficult to understand. So I want to explain that in a very simple form, wherein all of us can understand what they are. They are not as complicated as they seem to be. Let's unlock them one by one. This is going to be a part of multi-part series. So today we'll go ahead with part one. The first thing that I wanted to discuss is about integration. Mostly, integration is there in every software project. Without integration, I don't think you can have big projects running. So what is integration? Integration is nothing but connecting multiple systems through a common approach. Multiple systems could be your ERP, CRM, HRIS, banking, so many systems, trading, right? And each of these systems are maybe built in different technologies, different platforms. They may exist in different locations. So your in-house system might be expecting some amount of data from those systems, mostly master data. Master data are data that identify sometimes HR master data is nothing but your employment data, your personal data, your educational data, something like that, right? For each domain, master data differs. So mostly we integrate systems for master data, but there are other integrations as well for transactional data as well. So integration is nothing but moving data from point A to point B in a format which is being understood by both the parties. So in order to integrate, people talk about API based integration or file based integration, right? So both are different. What is an API based integration? API based integration is nothing but you have something called as an application programming interface, which is nothing but a software piece, a piece of software which exposes some variables that can be moved to another uh, area or another moved to the other side of the system in a commonly understandable format, right? And that format can be something like JSON or XML, which are generic, which are not based on any technology or framework, and it is highly human readable, right? So system A has an API, system B has an API. So when we say system B consumes system A's API, it means that system A sends data in a format understandable and agreed upon by system B, right? That's what is called an integration through API. Now, what is REST? REST is nothing but representational state transfer, which is architectural style, where we use HTTP verbs like put, get, delete, etc. to operate upon resources like documents, images, web pages, files, etc. Right? So that's called REST. So they call it as REST-based APIs, which means REST-based APIs are usually done in JSON format. Not necessarily JSON, but JSON is being used because it is a lightweight data exchange language. So we do integration through an API in the form of REST transfer through an intermediary language like JSON or XML. So that's all about integration. Again, I'll summarize. Integration is connecting two or multiple different systems through a common language using something called as API, and both the sender and the receiver agrees on the format of the data that is being sent and received. Now, encryption is very frequently used terminology. It comes along with security. Now we have in encryption, what is encryption in the first place, right? So if I send my password without encrypting, somebody from system A to system B, if somebody intercepts that traffic and finds my password, they can go to another machine, key in my password, and take all my data, right? That's how unsecure I send my data without encryption. So encryption is nothing but just jumbling the words, or replacing text by a word or something like that, right? So ABC can be told as 456, or it can be in binary form, or hexadecimal form, or there are a lot of ways in which you can basically mask the data, from uh, which mask the data, and it could be understood only by the sender and the receiver. So that's pretty much what is called encryption. So there are two types of encryption commonly being talked about. One is data at rest, and another is data in transit. Data at rest is nothing but you encrypt the data stored in the database, the persisted data, right? So why we do that? Because if the database has unencrypted data, anybody could come and if somebody could hijack your database, they can uh, take all your data happily, right, and use it. So in order to avoid that, we encrypt data at rest using algorithms like AES-256. I'll come back to how it is being done in a short while. And data in transit is nothing but the data that gets moved from your system to another system, especially during integration or file transfer, etc. So for that, we use SFTP for file transfer, secure file transfer protocol, which operates on port 22. HTTPS runs on port 443. So these two are used for data in transit. And when I say data at rest and encryption, I told that I'll talk about how it is being encrypted. So there is a symmetric and an asymmetric encryption. In symmetric encryption, the same key is used for both encryption and decryption. In asymmetric encryption, there is a public and a private key, and the private key never leaves the owner. It is only with the public key that the data is operated, and the owner can only unlock or lock it using the private key. So that's about encryption. And one more thing I wanted to cover: this HTTPS can also be called as TLS 1.2. Most of the people call it as TLS 1.2. Now, what is key management system? So suppose I lock my door with a good key, and then I leave the key nearby. So what happens? There is no point in even locking, right? Similarly, when you encrypt your database and leave the encryption key in the database itself, it becomes very easy for the hijacker to attacker to pick up your key and decrypt the data and use your data. So in order to move those keys away from the encryption arena, you have something called as key management systems. And some big companies who want high security, they have hardwares for this. They are called HSMs, hardware security modules. But KMS is a service, key management service is a service which is there with most of the cloud providers, where you can, after encrypting, you can further encrypt the key inside the KMS using a master key, and you can do the encryption or decryption of your data keys only inside the KMS. This KMS can also be used for key generation, uh, key rotation, etc. So hope I covered everything in encryption. These are pretty much the major terminologies that are used as part of encryption. The next one is authentication. So authentication is the process of getting access through to a system through bypassing your credentials. There are two types of there are multiple types of authentication, but even your normal username and password based is a simple basic authentication. But SSO is what is being talked about much these days. The SSO is nothing but single sign-on. As the name implies, you sign in once and then use multiple systems through that particular through that authenticity of that particular sign-in that you do at the first place. Mostly, your Windows systems access your single sign-on interface to other systems that you use in your workstations. But if you want to do SSO between two different networks, then there are ways to do it. So basically, SAML is a standard way. But it is getting changed. People ask for OAuth also these days. SAML is nothing but it's an assertion based language wherein you need to exchange claims. Claims are nothing but some details about you, like your user ID or your email ID or your employee ID, along with some other details that has to be exchanged between your IDP and your system. IDP is a player. IDP is mostly an independent entity which provides or which brokers this particular authentication. So IDP stands between system A and system B. So once you log into your IDP, then IDP bypasses the what you call security for you to access system 3. System 1 and system, if you establish identity between system 1 and IDP, then you can access system 2 directly from system 1 without uh, authenticating, right? So that's about SAML based authentication. There is also one more called SP based metadata, IDP based metadata, SP based metadata, but usually people go for IDP based authentication. And OAuth is you have seen this in your daily usage of your tools like Facebook or Google. Credentials are being used for multiple web applications, right? You go to different web applications, they ask you to log in through either Facebook or Google. So how it works is a bit complicated. There is something called as a resource server, resource grant, and things like that. But simply to understand, it is a token based mechanism wherein you get a token from your resource server, and you pass that token to the granting server so that you can get your resource. So you don't have to put your username and password. Don't have to manage different username and passwords for each system. So you can use Google or Facebook's username and password to uh, sign into those systems. No, it's a bit complicated, as I said, but I have tried to explain it as simple as possible. Authorization is the next level of once you authenticate into a system, you need to be given privileges on which part of the application you can access, which screens you can access, which data you cannot access, things like that. And the most important type of authorization is role-based authorization, wherein if you're a manager, you have access to certain screens, approval screens are there for you as a manager. But as an employee, you don't have approval screens. You have only screens to apply, right? Likewise, a HR manager might have different what you call things to look at in the software. It depends, right? So based on your role, you are given either higher privileges or lesser privileges. It's all controlled through the role-based authorization. And security, it's again, we saw encryption. Now these are some other terms that we usually hear: firewall, IDS, anti-malware, DDoS, patch management, etc. So firewall, as you all know, is a security device which filters your all your network traffic and blocks certain things according to the rules that you set. For example, block all the traffic originating from this particular IP. You can set different rules in a firewall. So firewall is nothing but it is a kind of a compound wall around your network uh, with a watchman who will allow only people with certain characteristics inside, right? Certain what I would say credentials inside, and they can block certain people without those credentials. Intrusion detection systems, these are nothing but network level packet monitorings where systems monitor network packets for suspicious activity. So it's again a highly technical thing, but to put it in a simple perspective, IDS systems look for sniff for packets that contain vulnerable content or vulnerable data, and they detect that and they prevent it from attacking our network. Anti-malware is nothing but your antivirus software. I hope no more explanation is needed for that. DDoS is distributed denial of service. Here, what happens is you may have a web application. Your rival might send duplicate traffic, dubious traffic to your application. This fake traffic, which comes in enormous volume, completely flattens down your server. Your server goes down, and your genuine users will not be able to access this, access your application. So that's called a DDoS attack, and there are tools to prevent DDoS attacks as well. The final one is patch management. So every operating system has to be patched regularly, so that if there are vulnerabilities, attackers will exploit that as well. So that's about patch management. And that's all I have today. Maybe in another part, I'll go ahead with a few more terminologies. And if you have any questions, please leave them in the comment section. I'll be happy to answer them either through the comments itself, or I'll go for another session to uh, explain you on that as well. So with that, we have come to the end of this session. Thank you so much.